The goal of Lesson 6 is to understand and apply slope-intercept form. So equations can be written in different forms, and one of the most famous equations that you'll see all throughout high school is equations that look like this, or the form of the equation looks like this. Y equals mx plus b. And we refer to this in math as a slope-intercept form. And you hopefully can already tell why we might do that. Right? You already know what m is. What does m stand for? Yeah, it stands for slope. Okay. So when we look at an equation like this, whatever number is next to x is the slope. So you can already jump down to today's examples. Here's an equation. It's in slope-intercept form. Y equals a number x plus b. And b we're going to talk about in a second. Y equals 3/4 x plus 1. So looking next to x is my slope. Here's the x, here's my slope. The slope of this equation is 3/4. That's huge. I'm going to talk later about what it means if it's positive and what it means if it's negative. Okay. The second variable here, b, is going to stand for what we call in math the y-intercept. And now you can already see where it gets its name. Slope-intercept form. Notice it's not the slope y-intercept form. We're going to talk about why we call this a y-intercept a little bit later. So, huge in math, slope-intercept form, because it allows me to see the slope of this equation is 3/4. 3/4 is a positive number. So what does that mean about the line, thinking about the other lessons we've worked on? If I graphed this equation, I made a line, is it going to be increasing, decreasing, constant, or undefined? It's going to be increasing because the slope, m, 3/4, is positive. Good. Well, let's prove that this is true. Let's make a table. Okay? So we know how to do this. And I'd encourage you to pause the video and try it on your own. But when I pick my x values, I'm going to pick a negative answer, 0, and a positive answer. And I'm going to choose multiples of 4 because I'm paying attention to the denominator. So then I write my rule. And then I plug in my values of x. We're going to plug in -4, 0, and 4, all in for x. And I'm actually only going to do the first one because I'm going to use my calculator to get the output y. So I'm plugging this into a calculator. (3/4) times -4 plus 1. Okay, I input -4 and I get an output of -2. So the coordinate of my first point is -4, -2, right here. And I could do that for each of these. Again, you can do this using a calculator, just plugging in your inputs and getting an output. When you plug in 0, you get 1 as an output, and when you plug in 4 for x, 3/4 times 4 plus 1 should give us 4. So the coordinate 0, 1 is on the graph, and the coordinate 4, 4. And we were asked, we wanted to prove that because this slope is positive, we should have an increasing line. Well, if I take my ID here and I connect the coordinates, remembering that this goes on and on and on forever, so I draw arrows and I extend my lines, we can see that this line is increasing. It's going up. So we proved it. Our slope is positive, we have an increasing line. But what I want to focus your attention on is the two parts of this equation. 3/4 and 1. The slope of an equation, the slope of a line, is the change in y over the change in x. And we can see this. What's the slope of this equation again? 3/4, right? Here we go. 3/4 I can see on the graph. Because if I move from point to point, I always do the same thing. I go up 1, 2, 3, up 3, over 1, 2, 3, 4. Up 1, 2, 3, over 1, 2, 3, 4. Always moving that constant rate of change. And now, for the really interesting part, what about the y-intercept? We haven't talked about this at all, but can I see this on a graph? The y-intercept is whatever number is being added to the x. Okay? So in our equation here, we're adding 1. We call it the y-intercept because this value, 1, is where our line hits, oh my goodness, on the y-axis. So we call it the y-intercept. So this number plus 1 is where the line hits the y-axis. So we call it the y-intercept. Which is pretty cool. Because we can actually just graph this line if we know both parts of the equation. Okay? Let's take a look at the second example. See how we can avoid making this table. We can do this fast, we can do it fluent. We're going to prove this one more time. But this time there's a negative y-intercept. We'll talk about that in a second. First, I want you to look at the equation. I want you to say, what's the slope? Slope is next to x. What number is next to x in our equation? Right, -2. And remember, we like slope as a fraction. So even though the slope is -2, I like slope when it's a fraction form. So I might put it over 1. Well, the slope of this graph, or the slope of this equation, is -2 over 1. Remember, if our slope's negative, should our line be increasing, decreasing, constant, or undefined? Yeah, decreasing. Okay. Now, if we take a look at slope-intercept form, we notice it's mx plus b. mx plus b. Here, we have slope x minus a number. So something your teachers taught you last year is, whenever you see subtraction, you make it plus, negative. And that allows us to identify that the y-intercept of this graph is -1. And that's why we say it's a negative y-intercept. And now if I just know these two things, oh my god, I can graph the line. Are you ready? We said the y-intercept is where the line hits on which axis? The y-intercept hits the graph on the x-axis? No, the y-axis. So this graph hits at -1. Here we go, -1. There's a point on the line. To get my next point, or even 2 points, I use the slope. Slope tells us how to move. 3 over 4, up 3 over 4. That was positive, we went up. Now we're going to go down. -2 over 1. -2, go down 2. Always, 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 always go to the right. The only time you can change direction is up or down. Always to the right. Down 2, right 1. I make a point. Down 2, right 1. And then I can even make one more. Down 2, right 1. It's a constant rate of change. Down 2, right 1. Down 2, right 1. So, I can connect my points here. And something we did in class to show that this is actually the line, we actually made a table. And we said, okay, well, what if I plug in x is 0, 1, and 2? What would my outputs be? And you'll see they become negative 1, 1, and negative 5. Sorry, negative 3 here. Apologies. And these are the coordinates on our graph. 2, negative 5. So we summarized. We know that it's logical now that we know M is slope. Big thing today, B is the y-intercept. Why? Because any linear function intersects, it crosses over the y-axis when the x-coordinate is 0. Later on, we're going to be talking about if x is 0, well, slope times x is 0, and y will be equal to the y-intercept. Good. Pretty cool. Connecting representations there. So now, we've spent a little time actually doing this already. Now we just want, for example 1, I'm going to give you 4 equations. I want you to write the slope and the y-intercept of each one. And this is easy. Slope, m, is whatever is next to x. So I just look at this equation. What's next to x? 3. It's positive. Positive 3. Be careful of the tricks. If you see a minus, plus negative. To show my y-intercept here is not positive 1, but actually negative 1. Okay? So that's what we're trying to do. Look at the equation, identify the slope, identify the y-intercept. I'll also show you D. D has a slope of 3/5. 3/5 is next to x. B, I don't see. I don't see a plus something, minus something. Okay, so if I don't see anything, it's plus 0. The y-intercept is 0. This graph is going to start at the origin. And then the only other thing I want to remind you of is if you see no number in front of x, like in C, negative x, what number goes before x if you don't see one? Haha, oh, it's 1. Negative 1x. So that way I know my slope is negative 1, my y-intercept is 4. So I want you to try the rest. Try number 2. Choice B. And then try 1, 2, 3, 4. And then, in example 2, we need you to work backwards and write the equation. So now you're going to write an equation. And you're going to be given the slope and the y-intercept. Slope is 2/9, the y-intercept is 3. The equation is y, slope goes next to x, 2/9 x, y-intercept is positive, plus 3. So go ahead and try the rest of the problems, and then try the problems after it. See if you can use the trick. For examples 3 and 4, graph the line quickly, or if you need extra help, you can always make the table.